that basically said, I don't understand what this means and it annoys me, so kept shutting it off. Those are the sort of awareness and training things that we need to deal with. And we've seen it even greater with the expansion of broadband. I mean, my dad, who recently passed away, I mean, up until the time he died last year, had broadband. He's had broadband for 4 years. He was always on. He, you've probably heard the stories about whether it's a smart thing from a power usage way to turn off your computer and turn it back on or leave it on all the time. Well, he was on the leave it on all the time type basis. And he'd send me about 3 or 4 viruses a week and go, is this a virus? Yes, it is. Don't send these to me. When I come back down to visit, I'll look for it myself. And then I go back and clean 600-700 viruses off of his machine. But here was an individual who was using it on a daily basis, just didn't grasp the concept of some of the threats that were out there. So there was these 10 committees, and there were a lot of government things, a lot of bureaucracy involved, but the concept was very, very good, and it sort of, went through the government, discussions about should we do this, how should we staff it, and everything. It came to fruition of October of 2001. And our main job at that point was to create a national strategy. And I'm not going to bore you with the details, but if you have an opportunity, it's freely available on the White House website. It's whitehouse.gov/PCIPB, or you can just use your favorite search engine for National Strategy to Secure Cyberspace. So that strategy's out there, and that, of course, led to the creation of the National Cybersecurity Division with Homeland Security, which had the responsibility not to fix these things, because the government can't do it, you can't do it, I can't do it. We all have to do our part to secure cyberspace, but clearly it's an area where there has to be somebody within the government that sort of looks after this stuff, keeps using the cattle prods to move not only government but also industry to move forward. So I've sort of laid a lot of that out as sort of a background. I want to get into some sort of the meat of the discussion now and talk about some of the new technologies and the new threats and some of the things we sort of see on the horizon. This is the part I'd really like to get some perspective from you on, if you agree or disagree with some of the things that we're seeing out there. One, I think first and foremost, is this whole issue of application security. What we've seen in the early days was people doing attacks on networks. Network attacks was the big thing, and exploiting network technologies to accelerate privilege or to get greater privilege in an environment, move up the root authority or admin authority or domain authority in a Windows environment. We've gotten good about that. The idea, did anybody here attend RSA here a few weeks ago in San Francisco? One of you were there? RSA, and I've been going for years and years and years. I had a couple reporters come up to me and say, listen, they walked the floor of RSA. Am I seeing the same thing they're seeing? And I quizzically said, well, I don't understand. What are you asking me? I said, yeah, there's booths there every year. They're giving out free T-shirts. They have like a 7-foot model at one place, and they have people walking around with yak coats on, calling Hackistan and all that other stuff. So it's a lot of the drama there, but it looks pretty normal. And one reporter from USA Today said specifically, well, I'm not seeing anything really new. And I got to thinking about it, and there wasn't. Gone are the days of, gee, here's the new technology we've got to solve something. Look, a firewall, intrusion detection, intrusion prevention. We've been doing that for years now. We know how to do it. Whether or not we do it is a different story, but the technology's out there. You're going out and you're talking about two-factor authentication. I bet you say 1/3 of the floor was technologies about two-factor authentication, strong authentication, identity theft, this sort of thing, which I'm going to speak a little bit more to in a few moments. But there really wasn't anything new. And it's not saying that all the technology that can be developed to improve information security has already been built, but we're in sort of that stage now where we're saying, listen, the technology is maturing. It's the processes that are in many cases broken because we're not doing it. It's the people that's broken because they're not getting trained as they should. But clearly the landscape is changing. There were a couple things, though, that I think we're trying to bring the battlefield more toward the forefront. And that goes back to the issue, coming back to the main topic, about application security relative to network security. Network security did a pretty good job. But the issue is, network security, network exploits are successful in many cases today is because the applications that are now network enabled or internet enabled are being exploited. Look at the applications, whether it's a shopping cart on an online website, a word processing program, a iPod, iTunes program. You look at the applications, and we are constantly seeing patches being put out because people are exploiting the applications themselves. Interestingly enough, which is really, really scary, we've even seen vulnerabilities in security applications such as personal firewalls and antivirus software that with a buffer overrun or some sort of a coding error that gives them the ability to shut down that application and then surreptitiously come in and do bad stuff on the computer system. So one of the key things that we're seeing going forward is the application security. And it's interesting because when you look at this, that's sort of the cornerstone of what we're doing. Many of the successful exploits that we've seen would not have been possible had we had no vulnerabilities in the software. Now, I'm not crazy enough to think we will ever have software with no vulnerabilities. You know, as long as we have people writing code and we have the potential for vulnerabilities, they're going to be there. They're going to slip through some way or another. But I think we can do significantly better. One of the pieces that I think we sort of confuse, particularly in we're doing education and training and development, is confusing quality with security. Quality you generally will hear about. If you're an end user of a particular application and something doesn't work as advertised, you're going to be on the online support desk, you're going to be making a phone call, you're going to be doing a live chat session, you're going to be sending an email that says, this breaks when I try to do this. But security is not that obvious. In many cases, you don't know about it until something bad happens or somebody reports it. The bad guys generally go out there and say, hey, I just got into your computer system. They're sitting in the background, but something is going on. And so what happens is when you go back to the sort of beginning of this, something bad happens and somebody needs to figure out why, so they try to replicate it and they can't replicate it. Turns out it's a hack or an exploit due to a vulnerability, and you start going through that fire drill in a company, and let's say a medium-sized company that's building applications, not a big software house, and you go out there and you look at some of the issues that it takes. Well, number one, you have to try to replicate it. Then you have to sort of quality assurance it and do all this stuff. And just sort of the fire drill trying to determine what went wrong is about $100,000+ on an application. That's a relatively small application. We're not talking an operating system or a server or something like that. We're talking about just an application. Then you have to go through trying to fix it. All the dev time, consulting time, the testing time, the ability to send it out to customers and get feedback on what it breaks, what it doesn't break is another thing as well. And once again, that's about $300,000 in this example that I'm giving here. Then once you have it tested, then you have to deploy it. And that costs more money on top of that, oftentimes $200,000+ to do that. And that doesn't include that intangible, what's it do to your brand. You know, it's easy to blame it on a big software house, but many of these things are small applications that you've either developed yourself or you buy as some sort of middleware. So consequently, application security has been one of the big vulnerabilities now that we have sort of always looked to put the Band-Aid on. We really have to move forward in trying to fix these. We do have programs now. We have actual applications that go out there and do a lot of the manual work. Has anybody here done code review for developers? It's not something that you want to, oh, I'm going to go have fun this weekend. I'm going to look through 25 million lines of code, look for bugs. That's not a fun thing to do. So we have a lot of these automated programs that were in the past looking for quality issues, but not so much for security. So now we've seen the integration of those sort of things. We have actual software out there that looks not only for the quality issues, but also for the security issues, which does a great deal in reducing the number of vulnerabilities we have, which then improves the security overall. So from the application security, the only thing I want to close that aspect on is sort of building this into the software development lifecycle. There's always been this perception, and I haven't done any real development for almost over 20 years now, and when I did, I wasn't very good at it anyway. But when you look at the software development lifecycle, when you sit down and say, we're going to build an app that's going to do foo, whatever foo may be, it's got to be, this is going to be a cool GUI. It's going to be really one click to get wherever you need to get done, but it's also got to be done securely. So that's got to be built in the software development lifecycle. And the perspective is, no, you don't do whatever you do and then get to the QA and then find something's wrong and say, oh, sorry, we're behind budget, we're behind time, we'll fix that next revision. What you do is you build it in as you go along. When you write the code, you run an app on it to check the code for security. And then you pass it on, you go through the compiling, you go through the QA process, and